Our capstone project is a modular effects amplifier for electric guitars. Guitar effects pedals that can be chained together and connected to an amplifier already exist, but combining them into one system is a new idea. By combining the amplifier and audio effects pedals into one unit, our system makes things easier for the musician by reducing complexity and using less space on stage. While designing our amplifier, we focused on ease of use and accessibility. This informed decisions such as the handles for ease of transport, the large labels, and the ribbons to remove the effect modules. At a high level, our project can be broken into a couple of blocks. Audio comes in from the guitar and goes through the 5 effect modules. Each of these contains an analog circuit that will change the audio waveform. The modules can be switched around in position and enabled or disabled individually. After the effects modules, the audio signal goes into a preamplifier and then the power amplifier. This will take the low-strength audio signal that comes from the effects modules, equalizes the audio levels, and then passes the signal to a power amplifier. The power amplifier takes 48 volts DC and amplifies the medium-strength signal to a high-power signal which is fed into the speaker. All this high power produces waste heat, so in addition to the audio system, there is a cooling system. Most of the cooling system is passive, with vents designed into the top faceplate, but we also incorporate a cooling fan for the power amplifier. The electronics used in the amplifier require a couple of different power levels, so the amplifier also contains a power system. An AC to DC converter takes 120 volts AC from a wall outlet and steps it down to 48 volts DC. A series of smaller DC to DC converters step down the 48 volts to 9 volts for the effects pedals, the cooling fan, and the preamplifier. The whole system is enclosed in a hexagonal-shaped box, which we chose because hexagons are the bestigons. The enclosure is constructed of plywood, chosen for its light weight and ease of building with. With the enclosure constructed, we glued felt to the sides and back panels to give it a clean look and soft exterior. Lastly, the effects modules are mounted into a custom chassis we designed. The chassis is 3D printed and holds the connectors and ensures correct alignment of the modules when inserted. Between the chassis and the rest of the enclosure is a laser-cut aluminum frame that holds the chassis and all the user controls for the amplifier. During the start of the project, one challenge we faced was simply scoping out the project and figuring out the first steps we needed to take. Without any sort of organization or timeline on paper, figuring out those first steps was overwhelming. To help combat this, we used a project management software to create and assign tasks and develop a project timeline. This was helpful to define our first steps and make sure we weren't missing any important deadlines. Another challenge we faced is some of our circuitry not working properly. Unfortunately, the power amplifier does not function correctly, and some of our effects circuits are not working properly either. We think this may be because we used reference schematics for our circuits, but we didn't have enough time to do proper design review. Given more time, we would be able to troubleshoot the circuits that are not working and get them working, and with the modularity of the system, it's easy to bypass the non-working circuits. Over the course of the year, our team achieved several notable things. First, we were able to collaborate together successfully to complete a project. That takes communication, good documentation, and frequent team meetings. One important part of this was how we were able to have consistent team meetings twice a week throughout the whole year. This enabled us to keep track of our progress and help each other out if we needed to make sure milestones were completed on time. Overall, I think our team did a great job of communicating, working together effectively, and challenging each other to make sure that we came to a better solution collectively as a team. Now, we'll demonstrate the system working. While some of our circuits don't work, we are able to bypass them using external components in order to give a demonstration. summary, we designed a unique audio amplifier that combines audio effects modules into the body of the amplifier enclosure. It reduces complexity compared to traditional amplifiers, and is easy to use, and it looks awesome.